Continuing our video tutorial with clip B, we were editing R6. We gave it a value of 390 ohms, and then we unchecked the value box because we don't want the text value to appear on our schematic. It just clutters it up. And next we're going to edit component D1. Again, every component schematic symbol must have at least two attributes: a reference designation and a footprint. And now we use our connector tool, which is the box with the blue lines, to start connecting up our components. And now our schematic is fully wired up. But now we have to deal with the issue of the 7400. We've got 4 symbols and 1 chip. If you click on the component add tool, you can see which symbols are in use. And the way we're going to deal with the 7400 is we're going to make 4 clones of that symbol, call them N1, N2, N3. We're going to open them with the schematic editor and give them the correct pin numbering. On 2 of them we have to actually add a pin, and the way we do that is to select a pin, copy it into the buffer, paste from the buffer, rotate it, and put it in the right position. So now what we're going to do is erase the 4 7400-1 symbols, and it's going to leave holes in our schematic. And when we go to add new components, there's our new symbols, N1, N2, N3, N4. We're going to add each one in turn and drop it in its correct place. And as I go to my component add tool and select a symbol, I get a preview in the preview window. So 3 has pins 9, 10, and 8. Number 4 has pins 1, 2, 3, and 7. 7 is ground. Now we have a false connection in our schematic because we didn't have a true pin 7, and what we do is we highlight these with the selector tool. It turns red, and then just hit delete. So I'll erase the blue connector line, and now I erase this visual line which represented a pin. And then I go to my connector tool, again the blocks with the blue lines, and I'm going to connect pin 7 to ground. Then I'm going to connect pin 14 to our VCC line. And now what we're going to do is edit our switch and the input symbol. We're going to add an attribute to the switch. We're going to give it a footprint value. Here's our switch footprint. We're going to call it switch. Now the footprint switch does not exist. We're going to have to create that. And now we're editing the input symbol. I've got to make 3 connections to this board, and what I'm going to add is a footprint for a 3-terminal screw block. Click on close when you're done. Now that's a footprint that does exist. I can now edit the LEDs. We can add another attribute, and we can add the attribute description. We've got red, yellow, and green LEDs, and we can put that information on our schematic. And pretty soon we're going to be moving on to creating a footprint. This is an example of a footprint file, and we're going to make one of these pins square. We can make a round pin square by just entering square inside the last quotes. This is a big advantage of gEDA because all the files are in plain text. Our schematic is now done, and it should appear in our folder. It ends with the SCH. Now we're going to go to a terminal command line, and we're going to issue the command to generate the PCB board and the other files. It's gschh2 PCB-S-V for verbose, name of the file. And what you want from verbose is to look for error messages. And I see two elements could not be found. S1, can't find a PCB element for footprint switch. That's because it doesn't exist yet. Diode D1 does not appear to have a footprint. So what we're going to have to do is reopen our schematic with the schematic editor, click on D1, edit, and see what's wrong with the footprint. Now these additional files that you see here, command, net, and PCB, those are in error, so we're going to erase those. We reopen our schematic with the schematic editor, select D1. You can ignore these error messages. Pin sequence attributes are not necessary. We're now editing D1. Turns out there was a typo for the footprint of D1. I had typed 0.1 instead of 0.1. So of course it's pretty picky about file names. We're now in the PCB designer package, and we're going to create the footprint for the switch. If we go to view and grid size, we can change the grid sizes, and what we're going to do is lay down lines with the line tool onto the silk screen layer to describe a switch that's 1/4 inch wide and 1/2 inch high. So now we've got our 4 lines, and that's the outline of our imaginary switch. We go to the via tool, and we're going to drop in 2 vias on the component layer, which are going to represent the pins for the switch connectors. It can be proportional like this. It doesn't have to be anything exact, because this is obviously not a real switch and you're not making a real board. Open that new file up with a text editor, and you can see that it does not resemble a footprint element because there's many lines. It's a very large file, so it's not been saved as an element. So what we do is reopen with the PCB designer, select all visible elements, cut the selection to buffer, and what we have to do is with the crosshairs is click on a pin that defines that particular pin as pin 1. We're going to cut it to the buffer, press escape to stop the action. It's going to turn red and start moving around. And now what you want to do is say convert the buffer, which contains that outline, to an element. You can ignore this message. And now what you're going to do is save the buffer to a file. And there's going to be a dialog box opening up, and you're going to say save it to the switch.fp. Click on OK. It's going to ask you, should we overwrite? And you're going to say yes. And then the next thing you're going to do is close out PCB Designer without saving. This is very important. You don't want to overwrite the file that you just created. Go back into your file, open it with a text editor, and you're going to see that in fact it's now an element because it's a nice little short file. Element. And we got pin 1 and pin 2. And you already know how to make one of those pins square. Reopen that file with the PCB Designer because you're going to export it as a PNG, which means you want to have a picture next to the file which shows you what the footprint looks like. And that concludes our tutorial. Clip B, which will be continued on clip C, and now come the screen credits.